everyone, my name is Yash Maheshwari and welcome back to the class. So in the last class we have discussed about forces and the motion produced by the forces. So two types of motions were produced. कौन कौन से मोशंस थे? सबसे पहला जो मोशन था that was translational motion or linear motion and then rotational motion. Then we have discussed about torque, that is moment of force. So torque, what was torque? So torque का मतलब था basically वहाँ पे force की वजह से जब rotation होता है, so turning effect of force is called torque. सो द टर्निंग इफेक्ट ऑफ फोर्स के बारे में हमने बात किया था वहाँ पे. फिर मोमेंट के बारे में बात किया था कि किस किस टाइप से होते हैं, क्लॉकवाइज डायरेक्शन टॉर्क एंड एंटी क्लॉकवाइज डायरेक्शन टॉर्क. वी हैव डिस्कस्ड अबाउट कपल. सो दो फोर्सेस जो अपोजिट डायरेक्शन में लगती हैं पैरेलल टू ईच अदर, जिसकी वजह से कोई भी बॉडी रोटेट करती है, सो दैट इज नोन एज कपल. सो द लास्ट टॉपिक दैट इज देयर इन आवर कोर्स as per the reduced syllabus, this is center of gravity and balance point. So now let's talk about center of gravity. What is center of gravity? So in this topic we'll be broadly taking two concepts: center of gravity of regular uniform objects and center of gravity of irregular lamina. Lamina का मतलब basically यहाँ पे होता है कोई irregular object जिसका कोई shape जो है वो fixed नहीं है, that is known as lamina, right? So center of gravity of regular uniform object and center of gravity of irregular lamina, right? So what is center of gravity basically? So center of gravity is the point through which the resultant of the weight of all the particles of the body act. So basically what it is, so let's say we have this body, right? This is a body. It has particles. Everything is made up of particles, right? So this body is made up of small particles, right? Now these particles will carry some weight. Now what is weight? Weight is basically the earth is attracting each and everything towards itself. So the force of attraction of earth creates weight of the body. So let's say this particle has weight W1 which is directed towards the earth. See, आपको पता है कि जो हमारा ग्रेविटेशन होता है वो सब चीज को earth is attracting each and everything towards itself. So there is an force of attraction. This force of attraction is this force of attraction is exerted on all the objects in the entire earth, on the entire earth. So जितने भी objects हैं हमारे अर्थ के ऊपर, सबको attract कर रही है अर्थ towards the center of the earth, right? Now let's say this is an object. It is made up of various particles. This particle, the first particle, this is attracted towards the earth. Let's say the weight of this particle is W1. Similarly, the weight of this particle is W2. This is W3. This is W4. This is W5 and so on, right? Wn. So each and every particle will be attracted by the earth. Now if we algebraically add all the weights of this part of this body, all the weight of each and every particle, then the algebraic sum of each and every particle, will give us the center of gravity. So center of gravity is basically an imaginary point inside or outside a body, जहां पे हम ये समझते हैं कि all the mass of the body is concentrated at that point. So center of gravity is an imaginary point, जिस पॉइंट पे हम ये इमेजिन करते हैं कि अगर इस पूरी बॉडी का वेट एक पॉइंट पे हम लोग कॉन्सेंट्रेट कर दें, सो दैट पॉइंट इज नोन एज सेंटर ऑफ ग्रेविटी. सो दैट इमेजिनरी पॉइंट इज नोन एज सेंटर ऑफ ग्रेविटी. नाउ दिस सेंटर ऑफ ग्रेविटी कैन बी एट द सेंटर ऑफ द ऑब्जेक्ट, inside the object or outside the object as well. For example, this is a wire, right? This is a wire. The center of gravity of this wire will be somewhat at the center of the wire. So this will be the center of gravity of this wire. Now if we bend this wire in the shape of a circle, then in this case the center of gravity will lie at the center of the circle. Here the center of gravity is lying inside the wire, but here in this case when we have bent the wire in the form of a circle, the center of gravity will lie at the center of the circle. So here the center of gravity will change, right? So center of gravity is the point through which the resultant of the weight of all the particles of the body act. So अगर इन सारे points के weight को add कर दिया जाए तो इनका जो resultant weight आएगा वो एक point पे हम लोग imagine कर लेते हैं, and that point is known as center of gravity. I hope that is clear to you, right? Okay, let's move to the next part. Right. So now let's talk about center of gravity of irregular objects, right? First we'll be talking about center of gravity of irregular objects, and then we'll be talking about center of gravity of regular objects also. So what is center of gravity basically? So let's take an example. This is a cardboard, right? Now if we try to balance this cardboard on our finger, so there is only one point on this cardboard at which we can balance this cardboard. जैसे example ये मोबाइल है, इसको हम लोग अगर बैलेंस करें तो एक पर्टिकुलर पॉइंट पे ही ये मोबाइल बैलेंस होगा. सो दिस इज द पॉइंट वेयर दिस मोबाइल इज बैलेंस्ड. अब ये इक्विलिब्रियम पोजीशन पे, ये गिर नहीं रहा है, ये मूव नहीं हो रहा है, राइट? सो द पॉइंट एट विच द बॉडी इज बैलेंस्ड, this is basically the center of gravity. That is the point where the center of gravity lies. So now let's take I'm explaining you the experiment that is given in the book of how to find the center of gravity of an irregular lamina. Lamina का मतलब basically हो गया irregular object, right? So what we'll do is we'll make 3 holes at the boundary of this irregular shape. हमने 3 holes बनाए, इन होल्स को दिया PQR. इन होल्स को पाइवर्ट करके हमने इसको इस irregular object lamina को we have pivoted it at some point, and then we are tying this weight. ये weight जहां पे भी रुक जाता है we draw a perpendicular line. So let's say this is Q dash. Again what we'll do is we'll rotate this, and then we have pivoted it at point R. Again we have hung a weight over here, and then again when this comes to a stationary position we'll draw a line. Now where all the lines will meet, the point at which all the lines will meet will be the center of gravity of this irregular lamina. So this is how we find the center of gravity of lamina, right? So this is there in your book, but समझना easy हो जाता है जब आप कोई चीज देख लेते हो. So this is how we can find the center of gravity of any irregular object. Now let's talk about center of gravity of different geometrical shapes. So center of gravity of wire, where will be the center of gravity? At the center of the wire. It will be at the center of the wire. So the midpoint of the wire will be the center of gravity. Similarly, center of gravity for scale will be again the midpoint of its axis. That means x axis and y axis. इधर से भी बीच पे और इधर से भी बीच में, right? Similarly, sphere का भी center होगा, cube का भी midpoint of the line, right? So midpoint of the line joining the centers of opposite side, this will be the center of gravity. For hollow cone it will be 1/3 of the height from its base. Now hollow cone और ये जो cube है ये सब आपके कोर्स में नहीं है, ये सब सिर्फ आपको समझाने के लिए बता रहे हैं कि center of gravity कहाँ पे लाई करेगा, right? So this is center of gravity for irregular shapes. Okay, right? So if this is a disk, then the center of gravity will be at the center of the disk. If this is a weight of ring, so this is circular. अब इस रिंग के अंदर लाई नहीं करेगा, इस रिंग के बीच पे सेंटर ऑफ ग्रेविटी इज लाइंग, राइट? इफ दिस इज अ बॉक्स देन डायगोनल्स जहां पे इंटरसेक्ट करेंगे दैट विल बी द सेंटर ऑफ ग्रेविटी. इफ दिस इज एन triangle, equilateral triangle, then in that case center of gravity will lie at the point where all the medians intersect, right? So this is all about now. So the question says the width of the door is 40 centimeter. Okay, sorry, yeah. So let's say this is our door which is hinged over here, and it says the width of the door is 40 centimeter. Okay, so the width of the door is given to be equal to 40 centimeter if it is released by exerting a force of 2 Newton at its edge. So we are applying a force of 2 Newton over here at the edge of the door. Let's say this point is A. So at point A we are applying a force of 2 Newton, right? away from the hinges. So away from the hinges means we are applying the force over here, right? Compute the torque produced which causes the door to open. Okay, now we have to find the torque produced to open the door, right? Now first of all I would request you, each and every one of you, to make out the figure. अगर आपको क्वेश्चन सॉल्व करना है तो सबसे पहले फिगर बना लो. If you can draw a figure, then you can get the imagination of what is given in the question and what you have to find out in the question. So if you know what is given in the question and what you have to find out, then it becomes very easy for you to solve the numerical. Now let's see what is given in the question. So the question says that we are applying a force of 2 Newton. So force is given which is equals to 2 Newton, right? And the width of the door is given. So if we talk about the distance from where we are applying the force to the point where it is pivoted. So basically the distance between the force applied, to the point of force applied to the point where it is hinged, this distance is given to be equal to 40 centimeter, right? So now we have to find the torque produced. Now torque is given by tau and the formula is force into the distance. Now understand this very carefully, that the units of the quantities given, the units of the quantities that are given in the numerical should be same. Since the unit of force over here is Newton, therefore the distance should be in meters. It should not be in centimeter. So the first and foremost thing that we have to do over here is convert this distance which is in 40 centimeters to meter, right? ये चीज clear है यहाँ पे? Is this clear or not? Yes or no? So first we'll convert the distance that is given in 40 centimeters to meters. Now can anyone tell me 1 meter is equals to how many centimeters? 1 meter is equals to how many centimeters? Yes? ये तो सबको आता होगा. Right. 1 meter is equals to 100 centimeter. That's great. So 1 meter is equals to 100 centimeter. Okay. Yeah. So 1 centimeter equals to how many meters? 1 upon 100 meters. Great. Very good. सबको पता है, basic सबको आता है. Happy to know that. So 1 centimeter is equals to 1 upon 100 meters. Therefore 40 centimeter will be equal to what? Will be equal to 40 upon 100 meters, right? So cancelling 0 with 0, we'll get 0.4 meters. So the actual distance that we have to use in the question is 0.4, right? So let's find out the torque produced which causes the door to open. This will be equal to the force which is equals to 2 Newton multiplied by the distance. Distance is what? 0.4. So this is equals to 0.8 Newton meter. And it is very important to write the units of the answer. If you miss the units, then in that case marks will be deducted in the ICSE board examination. So it is very important to give your answers along with the unit, right? So 0.8 Newton meter is the correct answer. Is this for the question says the moment of a force 10 Newton about a point O is 4 Newton meter. Now tell me, what is the meaning of moment of a force? So moment of a force का मतलब क्या होता है? Moment का मतलब होता है the moment of a force. वो moment का मतलब क्या हो गया? Moment का मतलब हो गया basically torque. So in this question, first of all, we'll be watching what is given in the question. We'll have to note down what is given in the question. So what is given in the question is the torque which is equals to 4 Newton meter and the force which is equals to 10 Newton. So torque is given, force is given. Now what they are asking us is that the moment of a force 10 Newton about a point O is 4 Newton meter. Calculate the distance of point of application of force from the point O. So let's say this we are applying a force over here, right? We are applying force over here which is equals to 10 Newton and we are trying to rotate this bolt, right? So we are applying a force of 10 Newton over here and the torque that is produced by applying this force 10 Newton from point O. So let's say this is point O. So this point is O. We have to find the distance of the force applied from the point O. We have to find this distance. Now, according to the formula, so what we have been given, we have written it down. Now, according to the formula for torque, the formula is tau is equals to force into the perpendicular distance, right? So, force applied tau is equals to 4 Newton meter. Force applied is 10 Newton. So, let the distance be d. Okay, so let this distance be equal to capital D. We have to find capital D. So the value of capital D will be, we'll be shifting 10 to LHS. So this is in the form of multiplication. Left side pe jayega. This will become division, right? So this will become 0.4 meter. Since the force was given in Newton meter, so the final answer would be in meters. So the final answer is 0.4 meters. Now let's move to the next question now. The next question says, a mechanic can open a nut. A mechanic can open a nut by applying a force of 200 Newton while using a lever handle of 50 centimeter length. How long handle is required if he wants to open it by applying a force of only 50 Newton? Now that's a great question. ये question ICSE already board में आ चुका है. This is a board question. Previous year questions, which we say PYQ. So previous year board question. This is a previous year board question. First of all, let's understand the question first. So in order to understand the question first, again, we can draw a diagram and we can understand it in a better way. So the question says, a mechanic can open a nut by applying a force of 200 Newton. Okay. So let's say this is a nut opener again. Right. So this is a nut opener. My drawing is a little bad. Right. This is a nut opener. This is the nut. Okay. So a mechanic can open a nut by applying a force of 200 Newton. So by applying a force of 200 Newton, the mechanic can open this nut. A lever handle of 50 centimeter length while using the lever handle of 50 centimeter length. So the length of the lever handle is 50 centimeters. So that means the length that is given from the point where the nut is pivoted or where the nut is fixed, the axis of the nut, the distance from the application of the force to the axis of rotation is given to be 50 centimeter. Now in the question they are asking us is how long handle is required. Now they are asking is if we try to extend the handle, then how long handle is required if he wants to open it by applying of only 50 Newton. क्वेश्चन समझ में आया कि नहीं आया कि अगर वो 50 न्यूटन का फोर्स अप्लाई करना चाहता है तो उसको कितना लंबा हैंडल चाहिए. So basically, if we increase the length of the force applied from the point of the axis, then obviously the force required would be less, right? Since tau, that is torque, is equals to the force applied to the distance of the application of force to the point where the the object is pivoted. So if you decrease the force, you have to increase the distance, or vice versa. If you increase the distance, the force required would decrease. And if you decrease the distance, the force required would increase. So this is the case over here. We have understood the question. We have drawn the figure. Now let's see what is given in the question. Let's note down what is given in the question. So in the question it says a mechanic can open a nut by applying a force of 200 Newton. So what is given in the question is force of 200 Newton. The force is given while using a lever handle of 50 centimeter length. Okay. And the distance is given to be 50 centimeter. Okay. Okay. So in the first situation, what they have given is that the force applied to open this nut using the wrench is around 200 Newtons and the length of this is around 50 centimeter. So the first and foremost duty, our duty, is to convert this distance into meter. If we convert this distance into meter, this will become 0.5 meters, same as we did in the previous question, right? So the distance is given to be 0.5 Newton. So let's find out the torque required to open this nut. The torque required to open this nut. So torque will be equal to the force applied multiplied by the distance, that is 0.5. This will give us 10 Newton meter. Sorry, 100 Newton meter. 100 Newton meter. Now what they are asking is कि if we apply a force of 50 Newton, then how long should be the length of the handle, right? So now in the second situation, what they have given is, in the second situation, so according to the second situation, what they have given is that the force now, the force that we want to apply now is only 50 Newtons, right? So now they are asking us to find the distance, that is they are asking us to find D when the same nut is to be opened. Now this nut gets open when we apply a torque of 100 Newton meter. So that means this is the same case. इसी लीवर को हम लोग बढ़ा के लंबा कर रहे हैं. So the same torque would be required in the second case also. So the torque required in the second case will also be equal to 100 Newton meter, which we have calculated in the first part. Now according to the question, we have to find the distance D. So let's apply the formula again. So tau is equals to force into the distance. Tau is equals to 100 Newton meter, which is equals to force 50, and this is multiplied by the distance D. So let the distance be D. Now let's find out the value of D. So D will be equal to 100 divided by 50, that is equals to 2 meter. So that means the question says how long handle is required. So the handle should be around 2 meters in length. Is this? Move to the next question now. Again, it's a very important question, बहुत important question है. और यहाँ पे इस question को करने से पहले एक चीज आपको बताना चाहूंगा. So last जो मैंने lecture record किया था, उस लेक्चर में मैंने एक जगह पे कुछ गलत बताया था. क्या गलत बताया था उसको आई वांट टू करेक्ट इट बाय नाउ. सो गलत मैंने ये बताया था कि लेट्स से इफ वी आर अप्लाइंग अ फोर्स ओवर हियर, राइट, एंड इफ वी आर अप्लाइंग अ फोर्स ओवर हियर, सो इफ वी अप्लाई अ फोर्स ओवर हियर, राइट, this is a body which is, let's say, pivoted over at the center. Now if we try to apply a force at this point, so this force will try to rotate this in clockwise direction. ये जो force है ये इसको किस direction में घुमाने की कोशिश करेगी? Clockwise direction में. Yes or no? Clockwise और anti clockwise पता है ना? Clockwise means जैसे घड़ी चलती है, the way the hands of the clock move, right? So hand of the clock किस डायरेक्शन में चलते हैं? इस डायरेक्शन में चलते हैं. So ये होता है 3, 6, 9, 12, इस डायरेक्शन में चलता है. So this is known as clockwise direction, right? So if we try to apply a force on this object which is pivoted at the center, then this object would rotate in clockwise direction. Whereas if we try to apply the force F on this point, let's say this point is A and this point is B. Now if we try to rotate this object, if we try to apply the force at point B, this object would rotate in this direction, which is also known as anti-clockwise direction. Anti-clockwise direction, right? So this is clockwise direction, this is anti-clockwise direction. So if we are moving, if we are applying a force on this object at point B, then this object will rotate in anti-clockwise direction. Whereas if we apply the force at point A, this object will rotate in clockwise direction. Now in case of clockwise movement, so जब हम लोग clockwise direction को लेते हैं तो हमारा जो मोमेंट होता है, यहाँ पे जो हम लोग मोमेंट लेते हैं, मोमेंट, ठीक है, प्रिंसिपल ऑफ मोमेंट ये कहता है, प्रिंसिपल ऑफ मोमेंट के बारे में मैंने आपको वहां पे बताया था, POM, POM, प्रिंसिपल ऑफ मोमेंट. प्रिंसिपल ऑफ मोमेंट कहता है कि इफ एन ऑब्जेक्ट इज एट इक्विलिब्रियम, देन इन दैट केस the moment in clockwise direction will be equal to the moment in anti-clockwise direction. That is, the force which is rotating this object in clockwise direction will be equal to the force which is rotating this in the anti-clockwise direction. Clockwise direction में हम लोग जो moment होता है उसको by default लेते हैं as positive, sorry, negative. Clockwise direction में we take it as negative. In the video I have explained that clockwise direction में positive लेते हैं, which is not true. The correct answer is in the clockwise direction we take it as negative, whereas in anti-clockwise direction we take it as positive. So anti-clockwise direction में positive मानेंगे moment को और clockwise direction में negative मानेंगे moment को. ठीक, right? Now understand how to learn this, how to remember that clockwise direction में negative होता है और anti-clockwise direction में positive होता है. So एंटी क्लॉकवाइज डायरेक्शन, एंटी को याद कर सकते हो, मैंने बचपन में ऐसे याद किया था, एंटी को याद किया था एज आंटी, एंड क्लॉकवाइज डायरेक्शन सी से होता है चाची, राइट? आंटी और चाची इज सेम, चाची इज अ हिंदी टर्म, आंटी इज अ इंग्लिश टर्म, मीनिंग ऑफ बोथ द टर्म्स आर सेम. सो हमारी इफ वी आर इन अ इंग्लिश मीडियम स्कूल तो वहां पे अगर हम चाची बोलेंगे इट विल लुक वेरी down, it will look very bad, right? So auntie is positive and the same auntie when becomes chachi is negative. So auntie, that is anti-clockwise direction, will be taken as positive. Chachi means clockwise direction will be taken as negative. Just a एग्जाम्पल टू लर्न, राइट? बाकी आप कैसे भी लर्न कर सकते हैं, जो आपको अच्छा लगे आप वैसे कर सकते हैं. ये छोटे छोटे शॉर्ट ट्रिक्स आप बना सकते हो अपने लिए टू लर्न थिंग्स, टू रिमेंबर थिंग्स. ओके, सो चाची आंटी से मैंने याद किया, यू कैन डू एनीथिंग व्हाट यू वांट, राइट? चलिए, so let's come to this question now and let us understand what is the question saying, right? So the question says that ABC are three forces, ABC are three forces, each of magnitude 4 Newton. So this force is of 4 Newton, this force is of 4 Newton, and this force is also of 4 Newton. Acting in the plane of paper as shown in the figure, point O lies in the same plane. What is the resultant torque about point O? So if this is the center point about which we are applying the force, then we have to find the resultant torque. Now we'll be using the principle of moment, POM. Principle of moment जो भी मैंने आपको बताया था, that the clockwise direction moment, clockwise moment will be equal to anti-clockwise moment. So principle of moment says that if an object is in equilibrium, then in that case clockwise moment is equals to anti-clockwise moment, right? This is principle of moment. Now over here we have to find that if we are applying force in 3 different directions and the forces are given by A, B and C, then in this case the net torque over here will be equal to what? So we have to find the net torque. So let's find out the net torque. So net torque will be equal to what? Net torque will be equal to the sum of the torques produced by the forces A, B and C. So let's see what is the torque produced by force A. So torque produced by force A. Now see, this force A is moving in this direction, right? So in this direction means it will try to rotate the object in this direction, yes or no? बताइए. अगर हम फोर्स इस डायरेक्शन में लगा रहे हैं, सो लेट्स से अगर यहाँ पे कोई ऑब्जेक्ट रखा होता, राइट? अगर ये हमारा रिंच होता, हम इस डायरेक्शन में फोर्स लगा रहे होते, तो ये क्या करता? ये इस रिंच को नीचे की तरफ इस डायरेक्शन में मूव कर देता, राइट? सो दिस डायरेक्शन इज व्हाट? दिस इज क्लॉकवाइज और एंटी क्लॉकवाइज? कैन एनीवन टेल मी? This is clockwise or anti-clockwise? Torque A, clockwise or anti-clockwise? This is clockwise, right? Right, clockwise, correct. So torque by A will be clockwise. Clockwise direction को हम कैसे लेते हैं? Negative लेते हैं, right? Clockwise को कैसे लेते हैं? Negative लेते हैं. So this will be negative of 4 Newton, that is the force, into the perpendicular distance. The perpendicular distance is what? 0.9. So minus 4 into 0.9 will be equal to minus 4 9 is 3.6 Newton meter. So this is the torque minus 3.6 Newton meter which is produced by force A. Is this clear to each and every one of you? Yes or no? बताइए भाई. Is this clear to each and every one of you? Yes or no? Anyone having any doubt? Please ask. No doubt? Great. Okay. Chalo, let's move ahead. Now let's come to the torque produced by force B. So let's change the color. Torque by B. So B is in this direction. So B will rotate the thing in which direction? B will try to rotate it in the clockwise direction. Yes or no? So B जो है इसको किस direction में घुमाएगा? ये भी इसको clockwise direction में घुमाएगा. Yes. So again clockwise direction में जो force होता है वो कैसा होता है? Negative होता है, right? So this will be equal to -4 into 0.8. That is equals to -3.2 Newton meter. This negative sign is only denoting that the movement is clockwise. Here also this negative sign is only denoting that the direction will be clockwise. That's it. ये negative sign और कुछ नहीं बता रहा है, सिर्फ ये बता रहा है कि clockwise घूम रहा है या anti clockwise घूम रहा है. That's it. ठीक है. Now let's talk about C force. Now this force C, this will try to rotate this in this direction. That is anti-clockwise direction. So let's find out torque by C, by the force C. So torque by the force C will rotate it. This will be equal to 4 into 0.6. That is equals to 2.4 Newton meter. Now what we have to find out in this question? In this question we have to find out the resultant torque. Now let's find the resultant torque. So the resultant will be equal to the torque produced by A plus the torque produced by B plus the torque produced by C. So the torque produced by A is minus 3.6, produced by B is minus 3.2, and produced by C is plus 2.4. Now let's add them. What is the final? So the final answer will be minus 4.4 Newton meter. So the resultant force is minus 4.4 Newton meter, and this resultant gives us a negative sign also. Now what does this negative sign signifies? So this negative sign only signifies the direction of the torque, the direction of the moment. So negative sign का मतलब क्या होता है? Negative sign का मतलब होता है clockwise, चाची वाला चीज, clockwise. So that means the torque produced, the resultant torque produced is 4.4 Newton meter, and the direction will be clockwise. So the final answer will be 4.4 Newton meter clockwise. ये आपको लिख के आना है. Negative का मतलब भी वहां पे आपको समझाना है कि what does this negative represents. So they are asking what is the resultant torque? The resultant torque will be 4.4 Newton meter clockwise. Correct? I think you enjoyed the class. I think आपको class थोड़ी अच्छी लगी होगी, चीजें यहाँ पे समझ में आई होंगी, जिस तरीके से मैं समझाने की कोशिश कर रहा हूँ वो आपको समझ में आ रही होंगी. So I hope you enjoyed the class today, and I'll try to make this make each and lecture very interesting and very entertaining for you all. So that is the main objective of my teaching. कि भाई हर चीज, जो चीज भी तुम समझो वो इतनी इंटरेस्टिंग हो, इतनी मजेदार हो कि उसको समझने में ही मजा आ जाए. मतलब पढ़ाई भी हो जाए, मजे हो जाए, और साथ साथ पढ़ाई भी हो जाए. राइट? सही है. सो वी हैव फ्यू मोर क्वेश्चंस ओवर हियर. These questions will be in the form of your homework. So this is the solution to this question. Okay. Now we have few more questions which will be given to you, which will be shared as the homework to you. So I'll be sharing this sheet with you shortly on the same application on the group, and we'll meet day after tomorrow. Till then, take care. God bless you all. Bye-bye. Jai Hind. And we'll meet day after tomorrow. Bye-bye. Take care. God bless you all. Do the questions, do the homework. Those who have not watched the first video, kindly watch it so that in the next class, we all are on the same page. Take care. Bye-bye. Right. Take care. Bye. About center of gravity.